Okay, I'm going to start with a difference between two different kinds of d's here. We've got d standing for distance and d standing for displacement. So what is the difference? Well, let's say you go out walking and you walk at a slow speed and then you speed up and then you slow down or whatever. No matter what, you're always getting farther. Your distance is always increasing. So your distance is simply how far. It's kind of like the mileage meter or the odometer in your car. All it knows is that the wheels keep spinning and the car just keeps going farther and farther. So distance is simply how far. Now, if you're out walking, this graph might be maybe you walked away at a certain speed and then walked at a higher speed, but then maybe you started coming back home. So displacement takes into account which way. So displacement is what we call a vector. And vectors are something where the direction matters. So for displacement, my definition is going to be how far from someplace. So if I, as an example, hop in my car and I drive to school, and then I spend my day at school, and then I drive home, I went a total distance of maybe 40 miles. Okay? But my displacement, that graph would look like this. I went 20 miles to get to Beaverton, and then after school got out, I came 20 miles home. So that's the difference between distance and displacement. For the purposes of this video, you could actually get away with slipping back and forth between distance and displacement. I think that would be okay. There might be some teachers out there who are freaking out about that, but I'm not going to. So let's start off with something easy for a DT graph. Let's say we've got this. Let's say that's a line. I drew it fairly straight. If this is a line, what does it show? It shows constant speed. How do I know? Well, I can ask myself a couple questions. I can pick a couple spots, maybe 2 or 3 spots, maybe like this. And at this time right here, the distance is there. At this time right here, the distance is there. And at this time right here, the distance is there. Whoa, that's not very good. Okay, that's a little cleaner. So as time passes, the distance increments go up steadily. So as you pass, maybe this is 1 second, there's another second, and there's another second. As each second goes by, the distance that you move, these are about the same. Maybe I didn't draw it perfectly, but it's okay. So that's a constant speed graph. But what if I drew this? What if I drew a distance-time graph that curved upward? Well, what does this show? Well, let's talk about it. Let's say I pick a few spots. Let's say I pick there, and there, and there. So these 3 spots right here. And look at how steep it is there, how steep it is there, and how steep it is here. What's happening is, as time passes, as more and more time passes, the distance is getting greater and greater, but it's going faster. So if I took this and made it into little straight chunks of line, like right here, right there, and right there, let's look at those chunks of line. This chunk of line right here starts there and goes to there, and look at how much distance is covered. The distance is only this much. But look at this chunk right here. It goes from here to here, and only a little bit of time passes. This is just a very little bit of time, but look at the distance. The distance that has passed is greater. So what this graph shows is acceleration. So on a distance time graph that curves upward, the object is speeding up. So what do you suppose a distance time graph that looks like this would show? Yep, that's an object that is slowing down. It was going fast, it's very steep, and then here it's gentler. So this is negative acceleration. Okay, so let's back up. For a distance time graph that has a straight line like that, that's tilted, we said that was constant speed. What would that look like on a velocity time graph? Well, on a velocity time graph, constant speed looks like this. It's a flat line, because as time passes, any time you pick, the velocity is going to be the same. So this is a constant speed graph as well. So these two graphs equal each other. Are there other cases like that? The second one we did looked like this. It was accelerating. Well, if a distance time graph curves upward, it's accelerating. What would that look like on a velocity time graph? Well, if time is passing and your speed is going up, then on a velocity time graph you would have this. So these two graphs equal each other. Kind of a weird concept, but if you ask yourself those questions, if you say, okay, so I pick a couple times, right here the line is this steep, so it's slow. Right here the line is that steep, so it's faster. And then here it's steeper still, so it's faster. Well, at this time the velocity is a small number. At this time the velocity is a higher number, and at that time the velocity is a higher number. So both of these show the same thing. So really quickly, just to finish, without giving away too many of my quiz questions, I don't want to give you all the answers, but what if you had a graph that went like this? That's supposed to be flat. What does this show? Well, right here, where it's tilted but it's straight, this is constant speed. And what about this flat spot over here where it's flat? What does this show? Well, as time passes, if the object doesn't change its distance, that means it is stopped. So how could I turn this graph, a distance time graph that looks like this, into a velocity time graph? What would it look like? Well, there's going to be two chunks. There's going to be this first chunk and this second chunk. How would I represent them? Well, the first chunk at constant speed is going to look like this. It's going to be a flat line, because remember, constant speed on a velocity time graph is a flat line. And then right here the object stops. So since the object stops, that means over here the velocity is going to go down. How steep is that? I guess that depends on how quickly this changes. But so these two graphs equal each other. Kind of a weird idea, huh? So anyway, there you have it. There is an introduction to dt and vt graphs and some of the types of quiz questions I could make about them.